Hello, today we're going to talk about how to solve an absolute value equation. And one of the things I think is so important to understand is that there actually is a way to solve equations consistently through all of Algebra 2 and beyond. And you first were introduced to this probably in pre-algebra when you learned something called PEMDAS. It does leave out some things, but it's a good way to start. So in Algebra 2, we use something that I like to call GELMDAS. And what that is going to upgrade PEMDAS to, instead of saying parentheses, it includes grouping symbol. And instead of just having an E for exponent, it includes something called a logarithm, which we will learn many lessons from now about what a logarithm is. But a logarithm is actually the inverse operation of an exponent. Then we have multiplication and division, those are inverses, and then addition and subtraction, also inverses. And that is how you simplify each side of an equation before you start. But you can actually reverse the process and start at the bottom and go upwards by moving terms around with addition or subtraction as your first step. Your second step will always be to eliminate coefficients and eliminate negative signs using multiplication or division. The third step, which will come much later on, is to eliminate the exponent using its inverse. There's a variety of them. For instance, one way to get rid of an exponent is to factor. And if you've learned about factoring in a previous math class, what factoring does is it eliminates a square. We'll talk more about that in lessons to come. Right now, in this lesson, we're not going to be doing this step at all because absolute value is actually a grouping symbol. And you typically will take that grouping symbol and then resolve what is inside of the grouping symbol by going back down to the previous step. And if you follow this procedure, you will always know how to solve an equation. You'll never be confused about where you are or what you are doing. So let's look at specifically what occurs with absolute value equations. Oh yeah, one last thing about this is please make sure, especially in Algebra 2, that you check all answers to see if there are what's known as extraneous. Extraneous means they solve algebraically, they work out when you do all these steps correctly. However, when you check them, you find out that they actually don't work in terms of the equation and what is given. And we'll see that in examples in just a few minutes. So looking specifically at absolute value is defined as the distance a number is from 0. So why that's so important is that if you look at this number line here, this distance here, okay, the distance that you're seeing on the left side of the here is 3 units. But that is the same as over here. This is also 3 units. So in the world of absolute value, -3 is the same distance as 3 from 0, making them equivalent. And that's the key to understanding this lesson. So to solve an absolute value equation, what you're going to do is you're going to isolate the absolute value symbol, the grouping symbol, using reverse GELMDAS. So we're going for this letter. We're going to set up 2 equations to represent the distance from 0. You're going to set the inside of that absolute value expression equal to a negative and positive value, and then reverse GELMDAS. And then you're going to check both solutions to make sure there are no extraneous solutions. Okay, in terms of inequalities, that's when you simply use a less than or a greater than symbol, or less than or equal or greater than or equal to symbol. You will solve the inequality the same way we just outlined above. But when you set up a number line to determine your answer, we're going to be using either an open circle, which is what we learned in Algebra 1. In Algebra 2, we actually learned that we can use parentheses, or a closed circle, which we learned in Algebra 1 for equal to signs. But in Algebra 2, we learned that we can also use a bracket to denote closed. Then what I like kids to do is I like students to draw a new number line that actually cleans up the graph. An example of what I'm talking about here is you may be solving an absolute value equation, and you may get a solid circle going to the right. And then you may get another closed-in circle going to the left. And students will frequently do this. Sometimes they'll even do this, right? But what you need to do is draw a second number line to denote that the actual answer is solidly between these 2 values. So you would just draw what looks like a barbell to denote that the answer is here. All right, let's take a